Hello everyone. In the previous lecture, we are discussed about the various types of the elastic constants and also we discussed the volumetric strain due to the single direct stress. So in this lecture, we are going to discussing about the volumetric strain due to three mutually perpendicular stress system. So in the diagram, we have to observe that one. Here we are applying the three direct stresses, that is the sigma 1, sigma 2 and sigma 3 in three mutually perpendicular directions. In previous lecture, we discussed the volumetric strain, that is the epsilon V equal to the delta V by V, which means change in volume divided by the original volume. So epsilon V equal to the summation of the strain in the three mutual perpendicular directions. Also, we have discussed the any direct stress produces a strain in its own direction, and also it produces the opposite kind of the strain in every direction at right angles to the applied stress. Then strain in sigma 1 direction, that is the epsilon 1 equal to the sigma 1 by E minus sigma 2 by M by E minus sigma 3 by M by E. Here 1 by M is the Poisson ratio. See here, sigma 1 by E is the direct strain produced by the epsilon 1 in its own direction. So here applying the tensile forces. So here elongation takes place. Then we have to consider the positive symbol. Similarly, so in the right angle directions, that is the sigma 2 and sigma 3, opposite kind of the strain it will produces, which means the elongation takes place. So that's why we have to consider the minus symbol in the remaining two direction. So contraction it will be takes place. That contraction value is the minus 2 by M by E. Similarly, sigma 3 by M by E. So this equation will become epsilon 1 equal to the sigma 1 by E minus of sigma 2 plus sigma 3 divided by the M by E. Similarly, epsilon 2 and epsilon 3 in the sigma 2 direction and sigma 3 direction, it will become the epsilon 2 equal to sigma 2 divided by E. So which means direct strain. So the nature of the stress is the tensile. So here elongation takes place, and remaining other direction, that is the sigma 3 and sigma 1 direction, it is the contraction it will be takes place. Then we have to take the minus symbol for the sigma 1 direction and the sigma 3 direction. So that is the minus of sigma 3 divided by M by E minus sigma 1 divided by M by E. So epsilon 2 equal to the sigma 2 by E minus of sigma 3 plus sigma 1 divided by M by E. Similarly, epsilon 3 will become the direct strain due to the sigma 3, that is the sigma 3 by E minus lateral strain in the remaining two direction, that is the sigma 1 and sigma 2 directions, that is the minus of sigma 1 by M by E minus of sigma 2 by M by E. So epsilon 3 will become sigma 3 by E minus of sigma 1 plus sigma 2 by M by E. Now volumetric strain, that is the delta V by V, that is epsilon V equal to summation of epsilon 1, epsilon 2 and epsilon 3. So then you have to substitute the epsilon 1, epsilon 2, epsilon 3 values. Then the volumetric strain equation will become the 1 minus 2 by M into sigma 1 plus sigma 2 plus sigma 3 divided by the E. So kindly remember this formula. So now we have to discuss about the one example problem regarding the volumetric strain. So let us consider the example problem. A steel bar 300 mm long and 30 mm and 30 mm, it's a cross section, and it is subjected to a tensile force of 150 kilonewtons in the direction of length. Then determine the change in volume and consider the Young's modulus value is the 2 into 10 to the power 5 Newton per mm square, and Poisson ratio is the 0.3. So first we have to understand the problem. Here let us consider the rectangular bar. So length is the 300, that is the, let us consider capital L. So length is 300 and its cross section, that is the width and thickness B and T, that is the 30 mm and 30 mm. And here we are applying the tensile force. So tensile force, let us consider the P value is the 150 kilonewtons. So in the direction of its length. So in the length direction we are applying. So now we have to determine the change in volume. So we know that when we are applying the force in the length direction, so the nature of the force is tensile force. So here in the length direction it will be elongation takes place, and the remaining two direction, its width and its thickness point of view. So both thickness and the width, so contraction it will be takes place, and its dimensions it will be reduced. So this same thing we already discussed. Any direct stress produces a strain in its own direction, and opposite kind of strain it will be produced in the every direction, every right angle directions. So first we have to determine the direct strain in the direction of its length. So that is the longitudinal strain. So longitudinal strain, that is the epsilon 1 equal to sigma by E. Sigma is the direct stress. So we know how to calculate the stress. Stress is nothing but direct force divided by the cross sectional area. Here very important, cross sectional area. So here we are applying the force in the length direction. So its cross section is this is its cross section. So here cross section area will become the its width and the thickness. So here I am considering the stress is the direct force, that is the 150 kilonewtons. So 150 into 10 cube divided by the cross sectional area is the width and thickness. It should be the 30 into 30. So stress will become the 30 into 150 into 10 cube divided by 30 into 30. But we know the longitudinal strain equal to direct stress divided by the Young's modulus. So here direct stress we know that is the 150 into 10 cube divided by the 30 into 30, and the Young's modulus value, that is the E value already given in data, that is the 2 into 10 to the power 5. So then have to solve this one. So we will get the strain value is that is the longitudinal strain value, that is epsilon 1 equal to 8.333 into 10 to the power minus 4. Similarly, we have to calculate the lateral strains, that is we know the relationship between the lateral strain and the Poisson ratios, that is epsilon 2 and epsilon 3 equal to the minus of, why it is the minus mean opposite kind of the strain it will be produced. So in the lateral direction it is produced is we are applying the tensile forces, so elongation takes place, but remaining two direction, that is the width and thickness point of view, contraction will be takes place. Then we have to consider in the strain is the minus of epsilon 1 divided by the m. So here 1 by m is the Poisson ratio. So 1 by m is the Poisson ratio already is given in data, that is the 0.3, and epsilon 1 we have calculated, that is the longitudinal strain, that is the 8.33 into 10 to the power minus 4. So this value and epsilon 2 and epsilon 3 values is the minus 2.5 into 10 to the power minus 4. And we know that when the volumetric strain, that is the delta V by V is nothing but change in volume divided by the original volume equal to the summation of sigma 1 plus sigma 2 plus sigma 3. So we know all the values. Sigma 1 value we know, that is the longitudinal strain, sigma 2 and sigma 3, that is the lateral strains, that is which is 2.5 into 10 to the power minus 4. Then I have to substitute these all values here. So 8.33 minus of here sigma 2 and sigma 3 having the same value. So minus of 2 into 2.5. So here let us consider the common value of the 10 to the power minus 4. The value will become the volumetric strain value is the 3.33 into 10 to the power minus 4. Then we have to determine the change in volume. So we know the volumetric strain, that is the 3.33 into 10 to the power minus 4. So which is change in volume divided by the volume. So now change in volume will become the volumetric strain into the original volume. Here original volume is the length into, so it's width and thickness. So here you have to substitute, so all the length and width and the thickness, that is the 300 into 30 into 30. Then the original volume will become the, so 27 00 and 00, so mm cube. So this is the original volume. Then we have to substitute, so change in volume is equal to the original volume into the volumetric strain. So nothing but, so it should be the, so 27 0000 into 3.33 into 10 to the power of minus 4. So then change in volume value is the 90 mm cube. Thank you.